think on its merits?
I've been having a discussion with Sly Sparkane on his latest video about laser tests. You know, he made a video claiming that low surface level laser tests are basically bunk because of the distortion that's happening near the surface. And I agree with that, actually, but you know, he stated in the same video that the Hawking's experiment, for example, was high enough, and they didn't suffer refraction because of that altitude above the surface. Well, I then shared our laser measurements and our elevation above the water surface, which was higher than the Hawking's experiment. So by logical deduction of Sly, there is no refraction in our experiments, you know, and the discussion, you should look it up. It's actually quite funny because, you know, he's dancing around that argument, and I just put the fire on his shoes. You know, our laser was at least double the height of the Hawking's experiment, and he then went on to find different errors, you know, in the experiment setup itself, but. You know, talking to these guys, they basically show that they have zero experience in you know, field research and engineering itself. They make assumptions based on their logical deduction without asking the questions to the guys that actually did the experiment. So they're making faulty assumptions, and they don't understand the process. You know, he said that the Hawking's experiment, for example. They measured the height of the beam along the way, and we didn't do that. But he doesn't seem to understand that the device we created actually removes that requirement because, you know, just by its design itself, I could elaborate on it if you guys want to, but the laser aiming device, we call it the SALAD, the super accurate laser aiming device, was specifically designed to remove the requirement of measuring the height of your beam over the water by a process of elimination with refracted and actual measured angles. You know, and if you understand how that works with regards to the trigonometry involved, now the SALAD device would not work if the Earth was not flat, or the surface we are shooting across is not flat, because it's using a GPS trigonometry system that automatically points the laser to a specific location. And that only works if the Earth is flat, because we find a reference location and we level the laser at the reference location. And the reference location is a lot closer than the actual target location. And the way we find the target location is by pure horizontal panning. You know, and if the reference location, for example, is 8 miles out or 5 miles out, and the target location is 25 miles out, it should not be on the same horizontal plane when we pan over to the new location. But these guys, they don't seem to grasp that.
They don't understand what a level transit is. That's
no,
we've come
exactly.
across.
You know, and if you have a target location at, say, 5 miles, and you level your laser, you put the beam at the exact height as the source itself, and then you pan over to your 25 miles location, by definition, the beam should have risen. But we never, ever had any elevation in the beam where we pan horizontally, apart from maybe a meter, you know, but that's just the tolerance, the error margin of the horizontal alignment of the device itself. Now,
the thing is with the refraction argument, we can afford to give them the refraction argument, even if they didn't. Our position is that they can't prove that the refraction even occurs, right? And they demand that it does, right? But let's just say, for argument's sake, that we gave them refraction. That don't make it sphere.
Hold on. I've got to interject there. I'm really sorry. So Sly has got absolutely no place discussing the merits of the type of refraction and the conditions that are involved in refraction, because he's fixed in the type of refraction that they use and apply. It's called terrestrial refraction. 7/6 of the Earth's radius. So Sly does this all the time. What about this? What about that? Well, you're not applying any of that. All you're applying is terrestrial refraction, an assertion that light bends around the radius of the Earth, 7/6 of that radius. That's terrestrial refraction. That's what they apply. Anything further to that or beyond that is nonsense because it's not their assertion. 7/6R, terrestrial refraction.
What they do is they assert it, but we actually put a method in the experiment itself to eliminate the possibility of refraction by having a calculated angle change towards an observed angle change. And if you are working with a refracted beam, what you change at the source should not correspond with what you see on the other side. You get it? There's an incidence angle and a refracted angle. And if you are working with a refracted beam, when you move your beam at a specific angle at the source, if it's refracted, then it should not correspond on the other side with the exact height difference. But it does, you know, every step that we move the laser up or down was exactly as it calculated out. So there is no refraction going on. And we actually added the calculated refraction by the Snell's law calculations we put in the document. But there's no mention of that.
Right.
Ever.
And when the Globers do it, none of that's applicable, none of that's measured, none of that's taken into account. It's just an arbitrary 7/6R.
Yeah. Yeah, and he was falling over the fact that in the document that we published, there was a brief description of the calibration process of the cellular device itself. Basically, we put in the document that we aimed the laser at the horizon to landmarks, and then after it got dark, we found the reference location. But you know, that's just basically a short summary of what actually goes on for calibrating the device itself, because now the device itself, it would not work if it's not completely level on all sides. That includes the device itself, but the beam also. They are not level, exactly level down to the micrometer, then the GPS targeting system would not work. It requires the device and the beam to be exactly level.
So you're essentially validating a level transit with an object that you can pan through that level transit, and if it wasn't level, it wouldn't give a return.
Exactly. Yes.
Yeah. So you've confirmed it's a level transit, and by doing that, you confirm the Earth is flat. You can't achieve that level transit on a sphere. It is impossible. Exactly.
And you get it right off the bat, and you don't even have to have the complex description of the experiment itself. Just the horizontal panning alone proves that there is no freaking curvature.
Absolutely. You've got a level transit because it's level. It's flat.
Yeah, you can do the same thing with zoom. If you zoom into and out of the horizon, you should see it rise and fall as a consequence of you getting closer and further away to the bulge, or the horizon bulge, or whatever they're going to call it. The fact that it doesn't do that, again, proves that it has to be a level plane.
Yeah. Yes. And yesterday, I think it was yesterday evening show, somebody challenged you, Anthony, about doing a test with a theodolite. Right?
Yeah.
Yeah. And what was the distance required to do that test? Because if you're using a theodolite over 100 meters, you're already stretching its specified limit.
Yeah, absolutely correct.
There is a limit to how far you can use that tool and still be accurate.
I want to just do a quick shout out along that line. Sorry to interrupt. So, I think he's just called Flat Earth Perth. He used to be called FECORE Perth, but Flat Earth Perth has been covering perspective in great detail. And what you've just said, it is Mike, isn't it? I've got your name right, haven't I?
Yeah.
Yeah. So what Mike has just said, in essence, backs up what FECORE Perth or Flat Earth Perth has been doing, which is a demonstration that the way it's rigged by people like Jesse when they use theodolites is that they ignore perspective. Now, this is something we covered a couple of months ago as well. We hammered this well and truly home, hopefully, to our audience. But there's other people that are doing the same and doing actual physical demonstrations of how the perspective works, what the theodolite does. And he does a very simple test. He lines something up with 3 or 4 Jenga blocks, shows that when you line it up with effectively the line being your transit, you look across that, you can show that it's perfectly flat. But then you go alongside it, or look down the line of it rather, and you can see that they're falling away. And you could say, well, that's Earth curve. Well, he's doing these examples on a flat table. And then he goes and does the opposite angle, shows it coming back the other way to show that there isn't actually a slope on the table. But in essence, you need to actually angle the theodolite down to account for perspective. But this isn't what they're doing when they use these, 20, 30 times zoom theodolites. They're doing it over about 20 meters. So it completely eradicates.
You only have to read the manual of a theodolite to see how much accuracy you get over a specific distance.
And it's short.
That just basically limits your measurements. And the same goes for auto levels. All the surveying equipments or surveying tools are all made for short distances. They are not made for long distance.
Absolutely.
We've been getting the complaints and sort of the arguments that we haven't used any surveying equipment because they're useless when you're doing long distance measurements. That's why we created the salad device, to remove the need for any measuring tools. It is a measuring tool.
These tools are useful for surveying because they've got enough zoom to overcome, now they would say in the textbooks, overcome refraction. I say bollocks, they're overcoming perspective with that amount of zoom over a very short distance. So they overcome the disadvantages of perspective by using zoom and a very short distance. And you only have to look at a surveying manual to know that they're not doing it over a mile. But that's what Jesse will do. He'll look over a mile and say, look, it's below the line. You're like, no, that's about as disingenuous as it gets. That's perspective.
Yes. Yeah. Well, I have to agree. And, Chris Van Maitre, who's also a member of FECORE, now he's a very, very experienced surveyor, and we've been discussing, what's going on with surveying a lot and why these guys are actually convinced that they are living on a sphere. And I will probably butcher Chris's argument, but Chris makes it very clear. All the distances they measure exact, and the distortion comes after they've put in the data. Then they superimpose that onto a sphere. So all the measurements are distorted because they superimpose it on top of a sphere. That's how you get those distances, but they are most likely not exact distances. And we've just developed a new experiment that we're going to do in 10 days in the United States. It's a short distance experiment, and we're going to test it ourselves first to see if the method is solid and the results are also solid. And then we're going to publish the document and put out a challenge to all surveyors and everybody that wants to use that equipment to do or repeat our test and find that there is no freaking curvature.
Absolutely awesome. We're going to take a short break. So with that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you like the show, maybe consider sharing it with a friend or subscribing if you've not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!